Okay, in section 7.5 we're going to review the techniques for graphing an inequality with two variables. Okay, we spent a lot of time on graphing lines in the past, okay, which is going to be very similar to what we're going to do here with inequalities. Okay, the difference is that the sign, of course, is going to be an inequality sign instead of an equal sign. And ultimately that's just going to require us to, instead of just graphing the line itself or the curve itself, okay, not only that, but also have some shaded parts. Okay, so the techniques are as follows. We'll demonstrate here in a minute, but ultimately we're going to draw the graph of the equation obtained by replacing the inequality sign by an equal sign. We're going to use a dashed line when we draw it if the inequality is greater than or less than, and we'll use a solid line if we have a less than or equal to or a greater than or equal to. Okay, these are again the same techniques that we learned in algebra and algebra 2 and geometry for that matter. And then once we have the line drawn, and keep in mind that we're using the line term here loosely, we could do this with a parabola or an exponential function or any of the functions we've dealt with. If they involve an inequality, okay, there's going to have to be either a decision on dashed or solid, okay, and then also a decision on where the plane needs to be shaded. Okay, so the checkpoint in number 2 here, we're going to check a point in each of the two regions in the plane to determine if the graph, or determined by the graph of the equation, and if the point satisfies the inequality, then shade the region containing that point. And if it doesn't satisfy, okay, then we will shade the other side. Okay, we really only need to check one point here, because if it makes the sentence true, we're going to shade that side. If it doesn't make the sentence true, we're going to shade the other side. You know, could you check points on either side of the line? Sure. Okay, you're just going to shade the one that makes the sentence true. All right. So let's see how that works with one inequality. We have, in this case, y equals 2x plus 4. Okay. So if I follow the procedures laid out, I would rewrite it as the equation y equals 2x plus 4. Okay, I would graph that line. Since it's a slope-intercept line, okay, I would choose to graph it using the slope and the y-intercept. So I would plot 1, 2, 3, 4 on the y-axis. That's my y-intercept. And then my slope is 2. So I'd rise 2, run 1. And then from there I draw the line, recognizing that it's an or equal to, I would draw a solid line. Okay. If it was just a less than, I would draw a dashed line. Okay. And then after that, the check part is to pick a point that's not on the line and plug it into the inequality and see if it's true or not. Now, if you have a choice, okay, I would always choose the origin because 0, 0 is an easy point to plug into anything. Okay? So if the only time you can't use the origin is if the line goes through the origin, then you got to pick something else. Okay? So again, it's your choice. You can pick whatever point you want. But for me, I would choose the origin. And if I put a 0 in for x and y, I'd have 0 less than 4, or equal to, that is. And I would recognize that sentence is true. And if that sentence is true, then I would shade the side of the line that the origin's on. So when I get done, okay, that would be my answer. Now remember that normally when we graph just a line itself, okay, any point on that line makes that sentence true. That's why, okay, this is the picture of all the solutions to y equals 2x plus 4. Any point that's on this line is going to make that sentence true. Okay, now our claim with an inequality is that any point, not only on the line in this case, but also in the shaded area, okay, is going to make this sentence true. So if we pick something like, let's say, the point 2, 1, okay, our claim is that since 2, 1 is in the shaded region, that it's going to make the original sentence true. So if I put a 1 in for y and a 2 in for x, I'm going to have 1 is less than or equal to 8. Is that true? Absolutely. Okay. Okay. Conversely, our claim is that if I have a point that's in this area that's not shaded, then it'll make the sentence false. So let's try, say, 0, 6 for argument's sake. If I put a 6 in for y, and I put a 0 in for x, I'm going to have 6 is less than or equal to 4, which is false. Okay? So that does not make the sentence true, and hence it's not in the shaded region. Okay? Anything that's in the shaded region should make that sentence true. Okay, questions so far? All right. Now, the other thing that we're going to look at today is graphing a system of inequalities. Okay? So we're going to solve a system of inequalities this time. So I'm going to make my coordinate plane. I'm going to graph the two equations that they would be if we were to make an equation instead of an inequality. Since this one is in standard form, okay, I would make an XY chart if it were me and find the intercepts. So I'm going to put 0 in for x, and I'll be left with 3y equals 4. If I divide by 3, I'd get 4/3. And if I put a 0 in for y, I would be left with 2x equals 4. And if I divide by 2, I'd get 2. So we'd have the point 2, 0, and the point 0, 1 1/3. And I would draw this line dashed because it's not or equal to. Okay, now I'm not going to shade yet until I do both, okay, because ultimately I just want to shade one particular area. Okay, so I'm going to hold off on the shading, and you notice that the next one is not a line, it's a parabola. So when we graph a parabola, we already hopefully know what that looks like without having to plot points, but if we do plot points, -2, -1, 0, 1, and 2 would be good ones here. We know 0, 0 is the vertex because it's just y equals x squared. It's one of our parent functions. But if we plot enough points, whatever the curve is, to graph it, 1, 1, 0, 0, -1, -1, 2, 4, -2, 4, and, oops, 2, 4, scratch that point. And if we graph this, notice I also drew this one dashed because of the fact that it's a greater than sign and not a greater than or equal to. Okay. And then if we test again, or if we test in general, okay, I want you to notice that when we have two different equations here, there's a bunch of different places where the shading could be. It could be in here, okay, it could be in this area, it could be in that little area right there, it could be over here, or it could be all this stuff over here. True? So what we need to figure out is if this is a system, okay, we need to show which points make both sentences true at the same time. Okay? So both sentences have to be true at the same time with whatever we shade. So let's start with the line. If we were to put the origin into the line equation, okay, it would read 0 is less than 4, which is true. So that means that we want the underside of the line, if you will. Okay, so I'm not going to shade anything quite yet. Okay. And for the parabola, do we want the stuff that's in here, or do we want the stuff that's out here? Well, if we were to take a point like, let's say, 0, 1, because that's inside the parabola, and again, we could take a point out here too. We can pick whatever point we want. But if I pick 0, 1, say for argument's sake, and I put a 0 in for x and a 1 in for y, it would read 1 is greater than 0, which is what? True. So that means we want above the parabola. Okay? So thinking about where that would be specifically, if I'm going to be not only above the parabola, but below the line, then wouldn't the shaded part just be this right here? Wouldn't those be the only points that would make both of those true at the same time? Okay. And so hence that picture right there with that shading, okay, is our answer. Any point that's not in that region that I have shaded, okay, would only make either one of the two sentences true or neither sentence true. Fair enough? Okay. So if you pick any point that's not in that shaded region, okay, it's either going to make both sentences false or it's going to make one of the two sentences false, because what we're looking for when we solve a system of inequalities, okay, is the area, okay, all the points that will make both sentences true at the same time. Okay. Questions so far?